Hello, this is Group 10's Project 2 Emergency Evacuation Time for University Library. This video will contain mathematical models of emergency evacuation time of the new library at the University of Birmingham. The equations we use are as follows. Time is equal to distance divided by speed. Queuing time is equal to number of people in the queue divided by 3. We begin with a simple model and model the room using the following assumptions. The library is represented as a single square room. The room is completely empty to avoid any obstructions. There is only one exit in the corner of the room. Velocity is 1.4 meters per second. The use of the above assumptions give us a basic starting point to develop our first model. Using an empty square room to start off, the model provides us with a simple shape to work with and ignores any differences in timing due to any obstacles. Having the exit in the corner of the room allows distances to be calculated by trigonometry easily. This is our first model. For Model 1, we chose to use a 10 by 10 room with one exit in the corner and no obstructions in the way to allow for simplicity. We modelled it with only one person in the room, in the opposite corner to the door, to find the maximum time it would take to exit. The limitations on Model 1 are as follows. Only one person is involved, it's an empty room, and it's not realistic. When it comes to peak queuing times, there's multiple scenarios. In the best case scenario is when everyone is already by the door, so there's no distance to travel, but there will be a queuing time. We use this and apply it to across the library to create a lower bound for the evacuation time. The worst case scenario is when everyone is in the opposite corner to the door, so they have to travel across the whole room and then queue to get out the door. This is applied to the whole library to get an upper bound for the evacuation time. And then there's a realistic scenario is when people are distributed throughout the library and individual rooms. It's more accurate than the other models, but it's not easy to model on a large scale due to the different distances for each person. We can now say the actual evacuation time is within these upper and lower bounds. Model 2 assumptions were the behaviour of the occupants under the panic situation are the same. Age and gender has no effect. All occupants are able-bodied and orderly queuing at fire exits. There's a constant walking speed of 1.4 meters per second. The fire doors are 1.5 meters wide. 3 people can fit through a fire door per second. We also assume that the approximate size of the library is a 70 by 70 meter room. The doors in the corner of the room. We simplified the libraries and added a wall in the middle of the large room. This allowed us to say that all the people below this partition went to one door and all the other ones went to go to the other door. If we apply the principles from the earlier model, we can work out the time it takes to leave each room and the worst and best times to evacuate the floor. Worst case, all 100 people in the bottom right corner of room 5 and leave at the exit at the top. First person takes 86 seconds to leave. The last person takes 120 seconds. For the best case scenario, 20 people in each room and are queuing at the door. The first person takes 15 seconds to leave, and the last takes 44 seconds to exit. The limitations of Model 2 are as follows. Only one floor is considered. It's not the exact shape of the library. It doesn't take into account disabilities. It doesn't take into account age. Obstructions are not considered, for example, bookshelves or fires in the path of people trying to evacuate. The assumptions for Model 3 are all the assumptions from Model 2. 6 people can fit down the stairs per second. Every set of stairs is the same. And when reaching a lower floor from the stairs, everyone on the floor below has already evacuated the floor. As in the previous model, we simplified the shape of the library. As before, we split the large room at the left such that the people above the partition move to the exit at the top of the room and the ones below move to the door at the bottom. In the best case scenario, in room 1 we have 38 people, room 2 we have 50, and room 3 we have 12. And everyone's queuing at the doors, but room 2 doesn't have a door in between the up and down stairs. So there's no queuing time for them. So from this information, the total time for everyone to leave the floor is 31 seconds, roughly. The worst case scenario, all 100 people are in the corner of room 3. This would cause the first person to take 62.13 seconds to leave, and 95 seconds for the last person. The limitations of Model 3 are as follows. It's not the exact shape of the library. It doesn't take into account disabilities or age, and obstructions are once again not considered. In conclusion, it takes 21.43 seconds to get from one set of the stairs to the other. So using this and the fact the library has 4 floors, and from the fact we've calculated the upper and lower bounds before. So the upper bound would be where it is the time to worst time to evacuate the 1 floor multiplied by 4 floors, plus the worst ground floor evacuation, plus the time between the staircases. And for the lower bound, it's the same, just with the best times instead. So the region for the time is 230 is less than or equal to t, which is less than or equal to 560 seconds.